Hey scrapers, welcome to another video. Today we're going to be talking about these little bench mounted furnaces. These are the electric ones, and what my experience has been with them so far, the pros, the cons, the costs involved, the crucible qualities and all that sort of thing. So yeah, let's kick into it. So to start with this crucible, with this little mounting furnace, I got it off of eBay. It was supposed to be an Italian model, but for some reason it ended up coming out of China and not being the Italian model. But that wasn't a problem. I got it, it was all good, it worked, it was fine. I took the sticker off the front because from what I saw online, when it gets up to melting temperature for copper, or any temperature really, the sticker just eventually melts off. So I thought I'd take it off to stop that problem. Yeah, and I did it the first time I used it, got it up to temperature. I did it gradually, not straight up to 1085 that copper melts at, and I usually have it sitting at 1130ish. I mean, the top temp is 1150, as I'll show you later on, and warmed the crucibles up, broke the crucibles in, or the crucible I should say that it came with, and no problem at all. So when I started to use it officially for the first time, there was a bit of an issue that happened, not at that point in time, but the second time I went to use it. The power cord, as you can see here, just down the side here, it's one of these type of 3-pinned plugs. Now I'll flip it over. I'm not sure if you guys can see that detail there, but just down here on the live pin where it comes in and then goes through to the fuse, you can see that it's all melted and that the fuse pins have gotten really warm. And so that was the second time I used it after I'd warmed it up 3 times to break the crucible in. And there's the fuse holder here, and as you can see, that's all melted and everything like that, and that sat inside. That probably won't fit now, but it sat inside like that. So it started to melt to the bottom of the terminals coming into the fuse after it went through the fuse back out and into the circuit. It started to melt this point here, and I thought, because the smoke was coming out of the vents at the side here, you see, and I thought something was melting and going to short out inside, but nothing happened. It wasn't until I decided, oh, hang on a second, it got up to about 850 degrees, and I thought, hang on a second, this burning smell hasn't gone away. It'll either wear out or it'll wear in, as they say, and it was still wearing out. So I stopped it, I pulled the plug out, and I discovered that where it touched here at the bottom through the live pin on the fuse, it was melting completely away. So I stopped it, and yeah, I had to do a bit of retrofitting myself. I went out and I bought another one without the, so it's pretty much just straight pin without the fuse, so it was pretty much just like that. I'll just quickly, I don't like doing that because you tend to loosen the connections here, but as you can see, it's not the original one. That was the original one, so I retrofitted just a plain 3-pinned plug there, and we retrofitted a fuse of our own. This draws about 8 amps at 240 volts, so there is a 10 amp fuse in here. So if there are any faults in the system, the fuse would blow before it destroyed anything inside, hopefully. So that was the first problem with this little furnace here. And of course I could have sent it back, but I didn't want to be without a furnace the first time I was using it. I was quite impressed with it. I mean, it's a brilliant little furnace for what it is, but unfortunately, yeah, there was a loose connection. As I showed you here, there's a loose connection on this pin. As you can see, I can remove that pin with my finger. I'm not sure if you can hear that. but that pin there creates the high resistance. The high resistance creates a more increase in current. The more current you have on a dodgy circuit, the warmer it gets, the hotter it gets, and that's why it melted. So that was that. And then so I started using it, as you do, and this is the crucible that came with it. Now I'm not sure if you guys can see that, but after my first copper melt, there was a whole lot of this pitting in here in the crucible here, in the graphite, as you can see. I'm not sure if you can see it, but there's a whole lot of pitting all the way around, and it's not too bad on the inside, but it must have pitted on the inside too. The reason I say that is because I tried to use the same crucible to melt brass, and I thought I'd cleaned it out after I had used it to melt brass, but obviously the brass had seeped into these pitted holes here, and then when I went to go melt copper again, the brass adhered to the copper, and when I poured it and it cooled, you could see that there was brass adhered to the copper in the melt, but there was no brass to be seen inside the crucible. The other thing is, this is supposed to sit like so, right? So it sits in there. I'll just move the camera up. So as you see there, there's supposed to be a huge big thick ring around here, so that the tongs that come with these melting furnaces can fit around. So as you see here, it works fine, beautifully now, but when you've got a couple of kilograms of copper in there, and that's doesn't sit in there because the groove has been worn away. Now I'll just put it back down again. So as you see here, guys, it's all worn away. It's no longer a groove, it's more like a concave half circle pattern now, and those, when there's a couple of kilograms of copper in this, it doesn't hold very well. And as you can see, the last time I tried it, I had to use a pair of long nose pliers to get it out, and I broke it here. As you can see, the chip out of there. So that's just going to be relegated to a mold. I pour some copper into there, and then I smash this, and then get the copper out of it in that respect. Now, the reason I think this has happened is because these furnaces, the top temperatures are 1150 degrees, and I don't believe that's hot enough. I mean, that's only at this point here. At this point here, when there's copper in it, or even up to the top, it's colder at the top than it is at the bottom. So as you're putting in cold copper, or copper that's not quite up to temperature as the bottom part of the furnace, the heat isn't there. So when you have the likes of this copper that's covered in this varnish, it smokes and absolutely carbons over like crazy. I don't have an example, but on the inside of the crucible there, you can see it's a lot darker than on the outside, and that for some reason, and I used quite a bit of this to melt because this is all I had in terms of, I didn't have any nice shiny copper to melt, and I had any of this grade 2 stuff, and I think that's what's caused this pitting. For some reason it's just eaten into the crucible, and it's worn the crucible away, something chronic, because I fear that these don't get up to the temperature of, say, a Devil Forge or LPG or propane powered furnace, so it doesn't burn all the impurities away because it doesn't have the heat. And so there's a chemical or atomic reaction at the top of the furnace here at the crucible when it mixes with oxygen in the air and creates all of this problem. I'll show you now because I've ordered some more crucibles. So an absolutely worn out crucible compared to a brand spanking new crucible. So you guys can literally see the difference of how it's actually been worn away or even eaten away on an atomic scale because of the corrosion and the reactions that have taken place from burning copper with varnish on it. So today we're going to break this new crucible in. I'm going to put it into the furnace, and I'm just going to take it up gradually from 0 to 250, 250 to 500, 500 to 750, 750 to the roundabout figure that I have at 1130, 1125, and this is how it should fit. See how it fits in there beautifully, doesn't chatter, I mean, it rotates obviously, but you know, there's hardly any movement in there, as opposed to this one where there's, you know, heaps of movement. And yeah, when you're trying to get out molten copper, you know, it was extremely dangerous. But I didn't have a choice, and I didn't think at the time that all I needed to do was let it cool down in the furnace and then just shatter it all out or smack this out. But yeah, you live and you learn. So that was part 2. So I wouldn't recommend, simply because it doesn't get hot enough at the top, to add dirty copper or number 2 copper once it's already full of molten copper. So try and burn your number 1 copper, or sorry, melt your number 1 copper if you can. And yeah, hopefully we'll try some more experimentations with this crucible, but not with dirty copper, to see if it gives me the same result. So, as I was saying before, guys, this was my first melt. This was my first pour with that crucible down there, as you see, and it came out relatively great. You know, I was really chuffed with this. A little bit of carbon and stuff like that, but you know, nothing too bad. And I'm pretty sure this was the good copper. This was a mix of good copper and number 2 copper. The melt itself wasn't the issue. The melt itself was, see, this is the second bar that I poured, which is pretty good in my opinion, you know, considering it's the first time I've done it, second time I've done it actually. And I was using this number 2 copper here, and yeah, and always wear a face mask. I can't, you know, reiterate that enough, or even say it enough. The fumes that come out of that varnish and stuff is just toxic, and it will give you an instant headache and make you feel sick and dizzy. But as you can see, this bar here has got a bit of carbon in it from the varnish that doesn't quite burn away, and then it turns to carbon. And even though I did skim most of it off, there was, for some reason, on another bar that I poured too, let's go and get it for you. See this bar here that I poured? Now, for some reason it's not nicely melted, because as I say, it's cooler on the top than it is at the bottom, obviously, because that's where the heat source is. And the other thing is too, is that if you add cold copper to warm molten copper, it will freeze, or it'll cool considerably. And because the temperature at the bottom is hotter than the temperature at the top, the convection current, when it freezes at the top here, doesn't quite work the same. So you have to stir it, and you always need to heat your stirrers to stop you know, steam explosions and the hot copper adhering to the cold metal. But for some reason, as it was melting, it wasn't, and I was stirring it as well, you know, try and stir up the carbons, because the carbon on the first pour sat at the top. It didn't sink like on this one. So as I poured it, because I didn't see any carbon or anything to skim off the top of this, the third pour actually, it's as I was pouring it, all the carbon spilt out into the crucible, into my mold, and yeah, and then just covered up at the top, as you can see. But at the bottom here, it's all, you know, not melted properly, which I thought was a bit weird. But the reason I've got a grinding mark in here is because I'm trying to cut it in half, but because it's tempered, I think that's the word to use, tempered, it's really difficult to cut through this tempered copper, because it's really tough. But yeah, what else was I going to add to that? Now, with the brass melt that I did, as you can see here, so you can see that there's copper here and there's brass here. But when I cleaned the crucible out, there was no brass left in there. What I thought anyway. But when I melted the copper, the brass had obviously adhered to the copper, and then when I poured it, it just, you know, came out like this. But for some reason, it turned out really manky on the top. So I don't know how. Yeah, I'm either going to have to remelt this or try and get rid of it somehow, but I don't think the scrapyard will take this as it is. And I tried my best to skim as much of the slag off the top as I could. Admittedly, I didn't have any borax. Maybe that's probably a contributing factor as well for not, taking the impurities out. But for the same instance, I skimmed as much of the slag off as I could. And what I thought was a nice, clean brass pour turned out to be quite manky looking when it had that, when I'd quenched it in water. So, yeah. And I'd always recommend. I mean, I knew it would happen. I was just too eager to wait for another crucible to show up. But I would always recommend using 2 different crucibles for different metals. I mean, I only plan to melt brass and copper, but I won't bother with the brass for now because of my bad experience. Maybe I did something wrong. I'm not sure, except for the borax. I'm not sure what else I could have done that would have been detrimental to the formation of the copper bar. So guys, we're up to 11:20, and according to this, I've been recording at 500, I think, for about 18 minutes. So it's taken 18 minutes to get from 500 to 11:20. So now what I'll do is I will open the lid and I will show you how hot this thing is. So as I say, it'll appear, this is pretty much orange, like a reddish, very deep orange, but on the camera probably show up as very white. And that's why they say you should use welding gloves, because normal gloves and stuff get very hot very quickly, and your forearms burn because of the heat. So let's make a start. Start turning it on. And we'll start running it. So hopefully it should take around 20 minutes to get to that, I'm not sure if you can see that now, that 11:20 preset. And I'll fast forward this bit so that it doesn't take the full 20 minutes, but in real time you'll still be able to see it on the stopwatch. And I have preloaded it with some copper, so as it's starting to heat up, the copper will melt, so it won't be adding cold copper to a hot crucible, which could shock the crucible and potentially crack it, and we don't want that cracking, especially at the bottom, because then the bottom will fill up with molten copper, and I assume then the furnace will be pretty useless. So there you go, guys. Around about 25 minutes, so I was 5 minutes out to almost get up to 11-20 degrees. Why it's going backwards, I'm not too sure. Maybe it's because there's a little bit of a breeze out here today, and that would affect it. And opening it as I did twice also would have sucked a little bit of heat out of it. So what I'll continue doing now is just doing the melt, because as I showed you yesterday in that white bucket, got all that copper to melt. So hopefully we can get through that today, and I'll video the progress every now and again. So for now, I'll just have you see what it's like in here. And doing, as I said, doing that all the time won't help either. The melt, because it's sapping out the concentrated heat that you need in order to get it to melt. Hey guys, welcome back. So I am about an hour and a half in to melting this copper. As you can see, I'm slowly but surely getting through this bucket, but still quite a bit to go. And also, I'm not sure if you can see in there, but it's starting to melt nicely. Just about to push it all down and start putting some more in, but I'll have to do it with my mask on because it's quite hot, so the varnish ignites and starts to smoke quite easily. So you'll see what I mean as soon as I put this copper in there. You'll see what I'm talking about. I'm not sure if you can hear me through the muffle of my respirator, but as you can see, that smoke started out pretty brown, went to like a light green, and now it is slowly getting to a whitish blue. Yeah, it does stink, this stuff. And that's why I'll be upgrading shortly to a dual forge, as these furnaces are great for hobbyists, but in this case where you want to melt large amounts of copper quickly and do it efficiently, so there's none of this burning off here, and because the dual forge has an open flame, whereas this is pretty much just, you know, current transformer inducted heat rather than flame heat, it doesn't burn off properly, and it smokes as you saw, and also doesn't get anywhere near as hot at the top as it does at the bottom of the crucible. So watch this space for the dual forge. Hey guys, welcome back. So pretty much melted all the copper, almost all of it. Not sure if you guys will be able to see that. I won't be able to hold it for too long, but nice. That copper is actually at good pouring temperature, as you can see how it's vibrating and it's kind of spitting. So what we'll do now is go over to the mold and then show you what to do with this mold. Always preheat your stuff. Moisture is busy being evaporated. You can see that. This here, guys, is what happens when you put cold copper in contact with molten copper. It freezes because of the temperature difference, and then it sits on top of the crucible rather than going down into the copper. You can create a hole for my headache. So now we're going to pour this, and hopefully it's going to be a beautiful pour. By the way, guys, that's quite hot. Whoopsies. See, I'm showing you guys what not to do. Right. So what we're going to do now, guys, is we're going to grab the crucible with the molten copper. As you can hear, it's popping out there like popcorn. And then we're going to pour it, and then from there we're going to tip it out of the mold, as you'll see, and then into the bucket to quench it. Here we go, guys, look at that. Beautiful. Can you see anything inside that crucible? Like there's no...
Still coming.
Yeah, there's no carbon or anything, is there?
No.
Beautiful.
Yes, there is.
So there you go, guys. The carbon is all the way at the bottom. For some reason it doesn't float on the copper, it sits on the bottom of these crucibles. So there you have it, guys. Not too bad from a little electric furnace. I mean, it has taken me almost all day to melt this amount of copper. So what I'll do is now is we put the crucible back inside this furnace. And there's leftover remnants, if you will. And then what we do, guys, is we close the lid, turn it off. In fact, you could have turned it off before you poured it, but either way it doesn't matter. And we let it cool down, so that the crucible and the internals of the furnace cool down at the same time. That way that it doesn't run the risk of any cracking because things shrink too fast or cool down too fast. But as you saw, that was a beautiful pour. In fact, that was better, far better than the copper bar I poured the first time I used this. So what we'll do now, these tongs are absolutely trash in terms of quality. As you can see, I think it's very loose, and I don't really know how to get in there without you know, destroying them. And they don't grip these molds very well, as you'll probably see. There you go. And just checking the back of that mold, see how hot that mold is still. But yeah, that's a beautiful bar there. I mean, from a little electric furnace. So what we'll do now is we'll move it over to the bucket of hot water, cold water, warm water, and you'll see it just yeah, heat this water instantaneously. That was cool. So it will still be warm to touch, but because I'm wearing leather gloves, it's not really an issue. And don't do that either, otherwise you run the risk of burning your hands and the smell. There you guys, look at that. That's a beautiful bar. Beautiful bar, absolutely fantastic. And this is my what? 5th pour. Some of it's all that wire, some of it wasn't. As I said, I stopped after I got this out. I stopped using the wire and I went and got some copper pipe and whatnot from the bin inside, and then I just use that. So for these furnaces I would recommend not using or melting copper wire unless it's 100% clean, because as you'll see quickly now, the same problem arises that I had in my first crucible. See how even though that's all carbon around the top there, sorry, excuse me, you can see that it's kind of eaten into the crucible again. So if you can get plumbing copper pipes and that sort of thing, or if it's clean copper like in grade 1, by all means melt that, but I wouldn't recommend melting varnish coated copper wire in these, as they're simply just not high temp enough in terms of burning off all the impurities, so it doesn't damage your crucibles. I'll just quickly show you how to get all that carbon out of the bottom of the crucible here. So we just pretty much grab this like here, like so. Clear a bench on your clear a space on your bench, and then just turn it all upside down. And there you go, relatively clean, and still super hot. Let's put that back in there, and we put that in there. Where's that lid? And this is what happens, even though this was heated with a blowtorch and left on the lid of this furnace, the copper still sticks to the cold parts. So essentially what I'll do is the next time I start a melt, I'll just cut them all off and put them in there first, and then when the copper gets up to, the crucible gets up to temperature, the copper will melt, and I can just pull the steel out. So yeah, thanks for tuning in, guys. I hope that was exciting for you. It certainly was for me. And that pretty much there is what came out of the number 2 copper coated varnish wire. So as I say, don't, if you can, refrain from melting that. Hey guys, so what I'll do quickly next is I'll show you how much that weighs, for those of you who are interested. It came out of a 3 kg mold, but that's not to go by for copper, because this won't be 3 kgs the next minute. So there you go, out of a 3 kg mold you're looking at 1.4 kilograms, but the density of that is just incredible. It's quite weighty, and it's still quite warm too, so as you can see I'm just stopping it from sitting on my hand for too long. But yeah, it's a beautiful bar, way better than the bar that I poured before, my first bar. It's a little bit uneven because of the grate that I was using in the freezer. Lid is bent in, so that's going to affect the flow. But yeah, polish that up and that'll look mint. No pun intended. So thanks for tuning in, guys. Look after yourselves. I'll catch you all in the next one. Cheers.